Hello and welcome to the final installment here for measures of spread. So the last two things we're going to deal with are percentiles and z-scores. So what is a percentile? A percentile, they're similar to quartiles, except now instead of having data divided into 4, we're going to divide all the data into 100 intervals instead of the 4. So for example, you may hear someone say that someone's in the 20th percentile. And what that means, percentile, it means that 20% of the people are below them. So the percentile indicates what percentage of the data falls below that particular one. So if you're looking at the 80th percentile, that means that 80% of the data is below. All right, so that's generally how it works. So we're going to be using our percentage skills from grade 9 to go through and do the example here. So the example I have, just extend it up a little bit. Okay, so Betty's entering the class and she ranks in the 20th percentile. She's in the 20th percentile. So what is her approximate height? So what I have here from earlier in the note, I have the class height in order from shortest to tallest. And now we know Betty's coming in. So Betty ranks in the 20th percentile. So P20 is the subscript indicates the percentile for Betty. So we know we have 14 people. And we're going to multiply it by 20%. Now remember, you multiply, when you multiply by a percentage, you multiply by the decimal value. So 14 times 0.2 will give us 2.8. All right. So how does that relate? So this is your population. This is the percentage. This will tell us how many people below. Oops, how many people below. So that's approximately 3. All right. So I'm going to look at it that way because it's an approximation anyway. So I'm going to look at 3 people off the chart in the order. So we have Claire's 1, Ellen 2, Stacy 3. So that means that 3 people are below her when she enters this class. So we could approximate her height to be in this region here. So I would approximate Betty's height to be about 160 centimeters tall. And so 2.8, really the 2.8 is in between, and I'll just show, it's really in between here, okay, just below Stacy. However, we're approximating it to be about 3, so it's about Stacy's height. That's what it ends up being. So therefore, Betty is approximately 160 centimeters, being in the 20th percentile. All right, so you just use the percentage to find out how many people are below Betty's height. B part. Mr. Agar is 177.5 centimeters tall. Determine his place in the class. So, just clean this up for a sec. 177, where does that fall? So 177.5 is right about there. So if we count down, 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 9 people below Mr. Agar if he enters this class, and there's 14. So 9 out of 14 times 100. So we're just doing a percentage. And again, here's your total. And here is how many below. So it's just rearranging the equation from above. And I'll just show that in a second. And when we do that, we find that the value is, oops, oh, wrong button. We find that it is 64.2, so 64.2%. So that means in this class, therefore, Mr. Agar is in the 64th percentile. Okay, so that means that 64% of the people in the class are shorter than myself. Okay, now I said I was going to show you, it's just playing with the formula. So if you look from above, we had the 14 times 0.2, so this is an aside here to help you out, equals 2.8. What I did then was I took the total, how many people, here I have how many people below, all right, and when we look here, this is how many people below, and we divided it by total number in the class, and here's the total number. So when you rearrange this equation, 0.2 equals 2.8 divided by 14. So it's just rearranging it, so it is this equation. If you're going to put something on the formula sheet, it's going to be total population times the percentage is how many people are below, or some version of that. So C part, determine the 70th percentile for this data. So that means that we're looking for P70. So that means that total number of people is 14. The percentage is 0.7. So quickly throwing that through the calculator, 14 times 0.7, we get 9.8. So basically, again, we're looking for person 10 on the list. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So Brandon is the 10th individual. And we could say that the 70th percentile for this class is 180 centimeters. So that tells you that if you are 180 centimeters, 70% of the class is shorter than you. So 70% of the class is shorter than 180 centimeters. All right, and that's it. That's how percentiles work. So often doctors talk about percentiles when they're talking about growth charts. So when you look at growth charts, if you go online, or people that are in the family studies course, the growth charts look like this, and then they have the dashed lines. And they're approximating a baby's growth. So if they're here, they might be in the 80th percentile. If they fall here in the graph, they're in the 10th percentile. So it tells them whether the growth is within an acceptable range. So that's an acceptable range of growth for a child. So that's an aside. All right. Finally, Z-scores. What is a Z-score? A Z-score, so that is a term, and we're going to be dealing with it quite a bit, especially in the next unit when we get to normal distribution. A Z-score tells you how many standard deviations a piece of data is from the mean. So if we know that, for example, an earlier example, the one number we came out with was 17 centimeters for one deviation. So that was our standard deviation earlier in the note. So our standard deviation then, it means that a Z-score equal to 1. So if we had a Z-score of 1, that means you are 17 centimeters from our mean. So just, it's another way to manipulate the data. And the Z-score formula is Z equals, and it's going to be your X minus X bar. So the data point you're interested in minus the mean divided by the standard deviation for the information. All right, so I've got an example that deals with that. So for the example that I have here, determine the following. Mr. Egger's Z-score, if he's 177.5. So from previous example, I'm not going to go through and calculate it again because eventually it's going to be all one question, especially on a test format. The mean for the class was 173.6, I believe, and we calculated the standard deviation to be 17.9 centimeters. So that's from earlier, from example 1. All right, so A part. What's Mr. Agar's Z-score? Well, you just go to your formula sheet, and at this point, Spreadsheet's not helpful because it's only one calculation. You can do it, but it's just easy to put the information in the calculator. So the x value is the data point of interest minus the mean, so the 173.6 divided by our standard deviation, which was 17.9. And when I calculate that, 0.5 minus 173.6 divided by 17.9, we get 0.21 or 22. So that's the z-score. And what that tells you is that my height is well within one standard deviation. So I'm 0.2 of a deviation away from the mean. All right, so it's 17.9. So for example, just to finish that off, if I went 17.9 times 0.22, so 17.9 times 0.22, I got 3.9 roughly. So almost 4. So if you take my height and you subtract 4, you would get 173.5, which is almost the exact same. So I'm looking up here. So if you look at the difference between 177.5 and 173, it is the 3.9. So the z-score is just telling you how far away you are from the mean. All right. So B part says Betty's height if her z-score is negative 0.15. Well, the nice thing with this part of statistics, once you identify the information given, it is just plugging into a formula. It's the interpretation that's the challenge. We know the z-score is negative 0.15. So what does that mean? If you look at, from my answer, I had a positive result. I had 0.22. So that was a positive result. And if you look at my height compared to the class average, I was above. So if you have a negative z-score, like Betty, you will find that you are below the mean. So our number should come out to be less than the 173.66. So here is, quote unquote, the heavy algebra here. We need to be able to use our grade 9 skills to solve for x. So remember, you would multiply both sides by 17.9. Inverse operations. That would cancel those guys out. So 17.9 times the 0.15 negative. So we get negative 2.685 equals x minus 173.6. Inverse operation would be to add the 173.6 to both sides. Canceling those. And we get x equals 170.9. So therefore, Betty is 170.9 centimeters tall. All right, so it's just manipulating that formula. So all I can really do on a test is test your algebra skills and take that formula and give you different pieces of information. So it's just a matter of being able to solve the values in that equation. So the homework on the next page here. Try that in the textbook and see how it goes. And if you have any questions, just let me know and I'll give you a hand. Good luck.